Hey Geometries, this is Mr. Blum, and this is lesson 2.6, Proving Angles Congruent. Our objectives today, to prove and apply theorems about angles. And make sure you write down the objective at the top of your notes. Now, a theorem is a conjecture or statement that you prove true. Okay, remember a conjecture, educated guess. A statement is someone makes a statement and you're going to prove it true based on facts. Vertical angles are congruent. Now, 1 and 3, 2 and 4, we learned that they're equal, but now we know that those angles are congruent. And we will refer to vertical angles as VAT. Vertical angles congruent. Whenever we use those, we're going to use that as VAT. So keep that in mind. Let's prove this theorem. To start, we write the theorem as an if-then statement. Okay, the hypothesis becomes the given, and the conclusion is what we want to prove. So, in our proof of theorem 2.1, vertical angles theorem, angle 1 and 3 are vertical angles. We know that, okay? And if they're vertical angles, we can look at this and say, all right, those are our given statement, because that's what we've been provided, and this is what we start with in our given. We are asked to prove that 1 and 3 are congruent. We're going to do this through this idea of congruent supplements. Now, we had congruent supplements in a previous lesson, and congruent supplement states this. If two angles are supplementary to the same angle, okay, then those two angles are congruent. So let's kind of theorize this out. 1 and 2 make a linear pair, so these are supplementary. 2 and 3 make a linear pair, so these are supplementary. Okay, so I know 1 and 2 are supplementary, and 2 and 3 are supplementary by linear pair postulate. Now, because they're supplementary, I know angle 1 and angle 2 are 180 degrees, and that's because of the definition of supplementary angles. And that's true here. Now, keeping in mind this idea, we're going to slow it down a little bit, and we're going to use substitution. We're going to substitute the fact that I know that angle 2 and 3 add up to 180. I'm going to substitute that in here for 180. So we are going to substitute that here. And angle 2 happens to be the same angle in both of these. Okay, now that's substitution property of equality. And now when I subtract, I can subtract the measure of angle 2 from both sides because it's the same thing. And I get the measure of angle 1 equal the measure of angle 3. And I did that by subtraction property of equality. Somebody should say by of equality there. So we're going to put that in there. Okay, we're using a property of equality. Okay. All right. So now 1 is congruent. Angle 1 is congruent to angle 3. That's what we are supposed to prove. But here's the thing. We have measures of angle 1 equal to the measure of angle 3. And we are supposed to prove angle 1 is congruent to angle 3. To go from measures of equality to shapes of congruence, we want to make sure we use definition of congruence. And that is our last step of this proof. Now, if you have questions about them, you can run it back through to try to figure out what's going on for each thing. You can also talk to your geometry teacher to see if they can help you out as well. Now, problem 1, using the vertical angles theorem. Now, we just learned that vertical angles are congruent and therefore equal by definition of congruence. So let's use that. Vertical angles are congruent by VAT and therefore equal by definition of congruence. So now I know that these are congruent and therefore equal to each other. And I have to have equality and able to use an equal sign. So that's why I'm using definition of congruence. Now, at this point, I'm in algebra land. I get to subtract 2x from both sides, and I have 21 equals 2x. Well, I subtracted, so that's subtraction property of equality. And remember, I'm working in equality. That's why it's a property of equality that we can look for our reason. Now I'm going to divide by 2 here, and I'm going to find that I have 10.5 equals x. Well, that's division property of equality. Now, I'm going to use something I don't have to because I was just supposed to find x, but generally when we find a value, we have x is equal to something, and I'm going to flip-flop these, and that's going to be x equals 10.5. I'm using a property here is called symmetric property of equality. This is the only reason I use symmetric property of equality. When I go from one way, 10.5 equal x, to the reverse of it, x equal 10.5. Okay, and that's symmetric property of equality for me to do that. Now let's go on to see this next one. I want you guys to go ahead and see if you got it. Kind of emulate what we just did. Okay, and you guys find x. Shut me off and check it out. Okay, welcome back. So now, again, 3x equals 2x plus 40, and that again is vertical angles are congruent, and therefore equal by definition of congruence. And then I'm going to subtract things on both sides, so I subtract 2x and x is equal to 40. Well, that's by subtraction property of equality. I hope that's what you had too. Now, in problem 2, we have a proof using vertical angles theorem. Now, vertical angles, remember 1 and 3 are vertical and 4 and 2 are vertical. 1 and 4 in this proof are provided that they're equal, in this case congruent to each other, and we're supposed to prove 2 and 3 are congruent to each other. We're going to use this idea of congruence when we do this. I've got my steps here, my statements here, and we're going to more talk about the reasons for why these statements exist. So first of all, every time you do a proof, you'll have your first statement is your given. The very last statement is what you're supposed to prove. Okay. Now, since the first statement is our given, we use given. So now let's investigate this other stuff. This is a fill-it-in proof, and I'm going to see about what I'm going to do next. They have 4 and 2, and they're saying 4 and 2 are congruent because now I recognize those as vertical angles. Now, before we continue on, I'm going to be using transitive property too. You see how these 4s are on the same thing? I can say that 1 and 2 are congruent because of transitive property here. I also will see 1 and 3 again here because they're vertical angles. And once I do that, I'll be able to see that 2 is congruent to 1 and 1 is congruent to 3. And by transitive property again, 2 and 3 will be congruent. So let's slow it down and let's see what's going on. 4 and 2, I know those are vertical angles. I'm going to fill that in. Remember, we call that VAT. Now that I know 4 and 2 are congruent, I'm going to go by way of showing you that since 1 and 4 are congruent and 4 and 2 are congruent, 2 and 4 must be congruent right now. And I'm going to talk about, or 2 and 1 must be congruent right now. And now I'm going to go, hey, 1 and 3 are congruent. And that'll be my link to show that 2 and 3 can be congruent to each other. So I'm looking at 1 and 2, and I'm like, all right, I've got this 1 and 2 connection with 4. So if angle 1 is congruent to angle 4 and angle 4 is congruent to angle 2, I know 1 and 2 can be congruent because of transitive property of congruence. Now, I've got 1 and 2 congruent, and I'm going to use that 1 and 3 vertical angles, and I'm going to use that with transitive property, because once I say this, I know 2 and 3 will be congruent because of this statement. So vertical angles theorem, and because of transitive property, I know 2 and 3 are congruent. Okay, read that over a couple times, reason through. If you're not sure about transitive property, go check it out and make sure you're comfortable with it. Remember, it's all about vocabulary, properties, and theorems and postulates. Now, here I'm looking at this again. Okay, we're going to use vertical angles theorem to prove the following: that 1 and 2 are congruent, are given, and we're going to prove that 1, 2, 3, and 4 are congruent. Now, how can we prove those? Well, we won't really talk about this yet. We're going to look at B in a second. Okay, so first, I get my given down. So I got my given. Okay, now I'm going to have this be my last line, and I've pre-done this, so I know that this is my very last line. Okay, so, and I wouldn't have known that if that there are this many steps in it unless I've already done it, just like a rough draft of a paper. Now, I know 1 and 2, and I'm going to do exactly what I did before on this. I know 1 and 2 are there, but I also know that 1 and 3 and 2 and 4 are vertical angles to each other. So by vertical angles, I know these are congruent to one another. Okay, and now I know that 2 is congruent to 3, and I know that 1 is congruent to 4 by transitive property. So 1 and 4, 2 and 3 by transitive property. Remember, 1 and 2 are congruent, 1 and 3 are congruent, so now 2 and 3 must be congruent. 1 and 2 are congruent, and angle 2 and 4 are congruent, so 1 and 4 must be congruent. That's how I was able to use transitive property. Now, since I further know that 1 and 2, since I know that everything's been set congruent to each other, by transitive property, I know all 4 of these are going to be congruent to one another. So I can use transitive property of congruence. Remember, it's property of congruence because I'm working in congruent signs. Now, the proofs we have looked at so far are 2-column proofs. There are other ways to write a proof. Another common type of proof is the paragraph proof. It is written as sentence as a paragraph. Okay, so now, when we're doing this, angle 1 is congruent to angle 4 here, and angle 2 is congruent to angle 3. 1 and 4 are congruent, 2 and 3 are congruent. Okay, so this is an example of a paragraph proof here. If angle 1 and 4 are given, 1 and 4 are given, okay, 4 and 2 are congruent because they are vertical angles, okay? So I know 4 and 2. And I'm on my way to prove that 2 and 3 are congruent here. So we got to keep that in mind, what's happening. So if 1 and 4 are congruent, I can prove that 2 and 3 are congruent and look at by transitive property of congruence. 1, 2 are congruent, and because if 1 is congruent to 4 and 4 is congruent to 2, 1 and 2 must be congruent. So that's transitive property of congruence. Now, 1 and 3 are congruent because vertical angles are congruent, okay? And by transitive property of congruence, I can say that 2 and 3 are congruent, okay, for the same reason. So this is our example of a paragraph proof. Now, the vertical angles theorem is a special case of our next theorem, congruent supplements theorem. Now, if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. So if I know 1 and 3 are supplements, 1 and 3 are supplements, meaning they add to 180, and I also know 2 and 3 are supplements and they add to 180, I got to be thinking about, well, if 3 is any number, just give number 3 a number like, I don't know, 120, okay? If 3 and 1 are supplementary, then 1's got to be 60. And if 3 and 2's are supplementary, then 2's got to be 60. These have to be the same value. So if I know that 3 is supplementary to these two angles must be the same measure and therefore this congruent to each other. And that's how congruent supplements works. Now, if we are going to write a proof proving congruent supplements, okay, now keep in mind, I'm proving congruent supplements, so in this proof, I have to pretend this doesn't exist. And I'm looking at given 1 and 3 are supplementary, 2 and 3 are supplementary. So prove angle 1 is congruent to angle 2. So the first thing I'm going to do is write down my given, and I'm doing this in the paragraph proof format. Since angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary, that's given. I know by definition of supplementary angles that the measure of angle 1 and the measure of angle 3, that because they're supplementary, is 180. And the measure of angle 2 and the measure of angle 3 are also 180. Okay, and this is by definition of supplementary angles. Now, because I know that, I can also set that measure of angle 1 and 3 is equal to the measure of angle 2 and 3 because of transitive property of equality or substitution. Okay, so these two are set equal to each other. But when I do this, I know that the measure of angle 3 and the measure of angle 3 are the same. So I'm really saying here that the measures of angle 1 and the measure of angle 2 are equal by subtraction property of equality if I subtract 3 from both sides. And now, because the measures are equal, I can use definition of congruence to make sure I show you that the angle 1 is congruent to angle 2, and that's what I was asked to prove. Now, I did this assuming that congruent supplements didn't exist, and I have my different lines at different shades of blue. What I want you to be aware of, if I was allowed to use congruent supplements, meaning if I wasn't proving congruent supplements, because remember right here, you will prove theorem 2.2 in problem 3. Hey, this is problem 3. If I was allowed to use congruent supplements, this is what the proof would look like. So I would know that since 1 and 3 are supplementary and 2 and 3 are supplementary, given by congruent supplements, 1 is congruent to 2, and I would have been done. Okay, so keep in mind, sometimes I have more steps because I'm proving another step in something, and we got to fix this while I'm here. So let's just fix that, and you guys can watch why that happens. Okay, and we can watch this while that happens. So we're all good, and we got that locked. Okay, so let's move on to our next one. Now, just like congruent supplements, we have congruent complements theorem. If two angles are complements of the same angle or of congruent angles, then the two angles are congruent. If angle 1 and angle 2 are complements, and angle 3 and angle 2 are complements, so angle 1 and 2 add to 90. Angle 3 and 2 add to 90. Just like I kind of mentioned in the congruent supplements, say this was, I don't know, 40 degrees. Then 1's got to be 50 degrees, and 3's got to be 50 as well. So they must be the same measure and therefore congruent. Now there's an extension to this. Theorem 2.4, all right angles are congruent. Well, we were talking about complements, and now we're talking about right angles. So we're looking at this idea 90 degrees. Well, if I know one angle is a right angle and another angle is a right angle, they're both 90 degrees, so they got to be the same measure and therefore congruent. So all right angles are congruent, and we come back and use this an awful lot throughout the year. In theorem 2.5, if two angles are congruent and supplementary, check it out, congruent and supplementary. So not only are they congruent, but they add to be 180 degrees. Not only are they the same measure, but they add to be 180 degrees. So we're saying that 1 and 2 are congruent and 1 and 2 are supplementary. Well, if they're congruent and they add to 180, they both must be 90 because they've got to be the same measure and they must add the 180 degrees. So 180 divided by 2 is 90. Okay, so those are the other two things that we've got going for ourselves. Now let's go on to this next problem. I want you to find out what are the measurements of angle 1 and angle 2 and angle 3. Well, if you really pay attention to what's happening here, I've got opposite rays going on out here. If I look at 1, opposite ray, and opposite rays, why am I talking about opposite rays? Opposite rays make vertical angles. So if 1 is opposite this right angle, that must mean that angle 1 is 90 degrees. Please use this idea of opposite angles to help you define what the measure of angle 2 and the measure of angle 3 are. Okay, angle 2, if I look at angle 2 here, angle 2 opposite rays, angle 2 must be 50. Oops, must be 50. And then angle 3, using the same idea, maybe it'll allow me to do this with highlighting the 40, it's going to be 40 degrees. So keep those in mind as we're going. Fair game when I'm asking you to find measures. Now, what is the value of x? Wow, Mr. Bloom, these look like vertical angles. And I know stuff about vertical angles because vertical angle theorem states that they're congruent, and by definition of congruence, they are equal. So I can set them equal to each other. And I don't ask you to justify your steps, so now we're off to the races in algebra land. Go ahead and solve. By the way, turn me off. All right, so welcome back. And you've got the solve going on. I looked at this and I subtracted 2x from both sides. So I got 4x plus 16 equal 40. I am now going to subtract 16 and get 4x equal 24. Dividing by 4, I get x equals 6. So I can plug this back in just to double check. And I'm just going to do the air double check. 6 times 2 is 12. So that's 52 on my right side. And I'm just going to write that in real quick. So I've got 52. Maybe I should bring that up here. Okay, let's bring that up here. and I didn't want to put that through, but that's 52 degrees. And now 6 times 6 is 36, plus 16 is 52 more. So both of them are 52 degrees. Now, that one's a nice one. Sometimes you come across something that's really nasty looking like this, but if I go inch by inch, it will find the answer in a cinch. I have x's are equal. I have this y, and I'm going to find x first. So I'm finding x. Vertical angles, we just did it, so I know these are equal to each other. And if I solve the vertical angles, I have 2x minus 20 equal 8, and 2x equal 28 after I add 20 to both sides. And divide, I get x is 14. Now I'm going to check my work just like I did, except I'll do it, with you watching. 5 times 14 minus 20 is 50. Well, I got to check this one too. So 3 times 14 plus 8 is also 50. So right now, I know that this is 50 degrees. So that equals 50 degrees when x is 14. And so is this. Because they're both 50, I now know that this 4y plus 2 must be 130 degrees. And now I'm going to use this idea of my linear pair here, 50 plus 130 is 180, to solve for my y. So 4y plus 2 equals 130. Subtracting 2, I get 128. And dividing by 4, I get 32. So that allows me to get this, and I plug that back in. 32 times 4 is 128, plus 2 is 130, and that's what I was supposed to find. So remember, we're using these properties we've been working on in this section to be successful, not only for doing statements and reasons, but also for setting up our algebraic relationships to solve. And we set those algebraic relationships up based on the things we know by vocabulary and by properties. Now, this is our summary. Use the lesson objectives in your notes to reflect on what we learned today. Objectives to prove and apply theorems about angles. Now, keep in mind, we should have everything marked off now. Okay, I've got apply law, syllogism, attachment. We got converses of given, converse and negation, compose inverse of a given conditional, compose contrapositive given conditional, compose biconditional statements, apply the law of syllogism, a law of detachment, write conditional statements in symbol form, prove conditional statements, use algebraic properties of equality, use properties of congruence, use the vertical angle theorem. All those were in this section. Okay, if I slide that down, gosh, look at all this stuff. This is now all checked off. Now, keep in mind, if you're not sure on how any of this goes or what's happening with these, you should make sure you talk to a geometry teacher near you. You either come on in the morning, the afternoon, during work time in class, ask questions during class when they are appropriate, or, you ready for this? Elk time. I hope things are going well for y'all, but remember, we got a test coming up and it's all about you and your success, so make sure you're making it happen. Have a great day.